Welcome to Workshop Wednesdays. My name is Megan. I'm the marketing manager here at Monolith Forensics. If you haven't been to Workshop Wednesdays before, what we do is every 2 weeks here at Monolith, we put on a practical digital forensics presentation. Sometimes it's about, practical topic, other times it's about concept. Usually our CEO, Matt Danner, is running these. But on special occasions like today, we have super awesome guest presenters come in and present for us. So we are going to have time for Q&A. So if you've got questions, kind of queue those up. And then when we get to the Q&A portion, if you want to come on and ask your question live over microphone, you can raise your hand in Zoom and I'll give you permission to do that. Otherwise, you can drop your questions in the chat. Um, I think that's it for my spiel. I'm going to go ahead and hand things over to our guest presenter, Cory Hall from Project Vic.
Thank you, Megan, and thank you, Matt, for inviting me to take part in this community engagement.
Yeah, of course. And thank you, Cory, for joining. Everybody, if you get a chance, thank Cory for doing this for us. He took some time out of his day while he's doing family stuff to do this for us. So I thank him greatly for coming on and helping with this. And everybody, this is a really interesting topic. So please queue up some questions for Cory as he's walking through it. And we're going to take hopefully the last 10 or 15 minutes of the webinar to do some Q&A. So please contribute if you can, and thanks, Cory, again, and I'll let you do your thing.
Great, thank you. So my name's Cory Hall, and I'm the CEO of Project Vic International, a nonprofit charity that's registered here in the United States. And we've been around for over 10 years, and our whole mission in life is to provide education and build technology capabilities to help our partners all over the world in law enforcement be able to find and rescue and safeguard children from sexual exploitation. With that said, today I'm going to talk about a new thing called the Crimes Against Children ontology. All right, before I jump into the details of that, I just want to introduce myself a little bit more. So I've got about 26 years of experience working in technology. I was in the military. I'm an Army veteran of the U.S. Army. I got a couple degrees in different areas of technology. And I've been at Project Vic as the CEO since this last January, but I've been a volunteer since 2019. And literally I started, I was working in a full-time job at MITRE, which is kind of like a big research think tank for the federal government. And I heard about this problem, and then I started learning more about it. And I found out that if you go around the world and you ask people working in criminal digital forensics environments, somewhere in the ballpark of about like 40 to 60% of the cases that they look at are about basically child safeguarding or child exploitation more specifically. So I had been looking at national security problems. If you've heard of like advanced persistent threat, sort of things, that's what I was focused on. And when I realized that about 50% of the investigations or the criminal investigations are child exploitation, I realized very quickly that this is the elephant in the room. And that started kind of a multi-year walk, which then now I'm the CEO of this amazing charity. We've got about 30 volunteers, mostly technologists, scientists, computer scientists, AI people, and law enforcement officers. And we work together every week. And so we're focused on sharing intelligence, equipping investigators with technology, and then also contributing open standards in our own research. So that open standards focus is really what I'm going to talk about today with the Crimes Against Children ontology. Okay, so 4 themes that I want you all to remember. Open foundation, shared meaning, easy pivots, and community involvement. So just say that with me here. Open foundation, shared meaning, easy pivots, community involvement. This really are the 4 things that underpin the rest of the talk. Okay, so let's talk about ontology. I've heard a lot of people say that ontology is a scary word. Really, it's not. Let me just demystify these things for you. It's a language. Just like we speak English, or maybe we speak French, we talk about cars or airplanes or computers. When I mention those things, all of you hear that and you immediately understand what that means, right? So what if we could take the language that we already speak here in the cyber domain and digital forensics and analysis, and then encode that into a language that basically computers can use. So we take the concepts that we talk about, things like investigators or devices or accounts, and then we encode them as nodes on a graph. And then the relationships basically help us pack in the meaning between, say, like, an investigator examines a device. Now, we all know these things, but what had been missing for a long time was an open foundation to be able to share that meaning. So that meaning is the ontology. And so I'm going to talk about a couple of ontologies today, but just diving a little bit deeper, ontology includes vocabulary, it includes relationships, and then it includes grammar. Okay, so the nodes, they carry the concepts. So like you see the person, online accounts, messages, investigative actions, and the edges carry the meaning. So you're going to see a couple of little graphs throughout the presentation, and this is what I mean. If I mention something like a node or an edge, now you understand what that means. Okay, so I talked about the words, right? So if we think about ontology for a second, like way back when we were really young, we learned the words. So like in grade school. And then as we got older, then we started learning about technology. Maybe we went to college or you got some specialized training. So then you started to understand things like accounts and messages and investigation and evidence. And through that exposure, you started to learn how to connect the ideas. So again, like going back to like the node and edge concept, but then there's the grammar, right? So if we speak any language, if we misuse the language, then somebody might look at us and say, I'm not sure I quite understand that. Can you repeat yourself or can you re-explain that? So if you like me, went through 10th grade English and you were, basically being graded by your 10th grade English teacher. I wasn't a very good writer, but my 10th grade English teacher was enforcing the grammatical rules on me. And while I hated it, now I'm a much better writer and hopefully a much better speaker. And through all that, I hope you all can understand me. Right, so let's peel the onion back a little bit more. We're going to start talking about some more technical concepts. So let's just say, as an example, we have 3 different data sources. We have a data source from laboratory A, forensic laboratory A. Maybe we have a warrant return from platform B, and then we have another case. Maybe it's a historical case that might come from from a colleague. And so we see these different types of data like user handles, account names, and screen names. So if you, like me, have encountered this, which I'm sure all of you have, then you are already pulling your hair out thinking about, well, how do I normalize this data into something that, that basically means something for me or my lab or my colleagues? Well, everybody's been doing this. Data normalization is a real pain. Now, with the ontologies, they provide this shared foundation and this common meaning. So I'm going to explore some more about what these ontologies are, but let's just say for a minute that we can map all 3 of those things into, into a common concept called an application account. And that in an ontology, like I'm going to talk about the unified cyber ontology, this is an observable. Okay, so it's just a fact that you can observe. Okay, so don't worry because we have automation to identify the concepts and map their meaning. So like if you have if you got a lot of data, then you have tremendous numbers of concepts. But now in the age of intelligence, we have kind of solved that problem. So data normalization is actually quite easy now. All right, so another way to think about ontologies is in 3 different layers. And each of these layers answers a different kind of question. Right? So at the top, we have upper ontologies, which you can kind of think about as like the philosophy of the universe. It's very abstract, right? It's going to take on concepts like entities or events or roles or things. And so you can build on top of that. right? So we build on top of that with a middle ontology. So in our case, we all work in the cyber domain. So we think about different objects or actions taken in the cyber domain, or identities in the cyber domain, or observables or facts that we can see, and relationships that bind it all together. And then we can build on top of that even further, right? So at Project Vic, we aren't worried about the entire cyber domain. So like I'm not thinking about, Chinese APT groups anymore like I used to, but I'm really thinking every day about how do we safeguard children. So last year, throughout all of 2025, I worked on creating an application ontology that builds on the foundation of this cyber ontology called UCO. And I pulled in many thousands of concepts and relationships between those. And so again, like we're really striving to build on open foundations and then be able to capture that shared meaning. All right, so as we keep pulling the as we keep pulling the layers of the onion off, we talked about the upper ontologies, the middle ontologies, and the application ontologies. So in our domain, we all work in some sort of cyber domain investigation and analysis. I just happen to work in helping safeguard children. So we have this upper ontology. There's actually a lot of upper ontologies, but for this purpose, for the CAC ontology, we've built on something called GUFO. We're not going to really dive into that too much, but then we took this unified cyber ontology, which is just an expression of hundreds of concepts that we all understand and we all speak every day. Think about files or hashes or whatever. And then there's another ontology that's closely related to UCO called the CASE ontology. This basically gathers all of the common investigation sort of concepts, like just the concept of an investigation or investigative actions, or like capturing provenance. So saying like, hey, our investigation gave us some sort of analytic result. Where did that result come from? So that's provenance. And so like we all in digital investigation and digital forensics, we all can use CASE UCO, right? So that middle ontology and that application ontology. And then depending on what kind of investigations you do, maybe you do fraud investigations, or you do national security investigations, or like me, I help lots of police with investigating crimes against children. So now, because we have these different levels of abstraction, we now can ask relational questions to like pivot through hypothesis. So I don't know how many detectives we have here, but detectives or intelligence analysts are constantly hypothesizing about like what does this mean? I've observed this person talking on the phone. Like, what could that mean? Or like, I've got 15 cases and I want to like do correlations across 15 cases. Now we can do that sort of thing. So like, if we want to ask a question about like what apps are used by crimes against children offenders in 2025 to target victims for extortion. Well, if you've got a whole bunch of crimes against children investigation data sources, now you can ask those questions using the graph. All right, so there's a lot of open source out there. I don't know the last time you guys looked at GitHub, but I'm on GitHub every day, and there's probably millions of repositories. And some of them are useful, but most of them are announced and then they're not supported anymore. So like how do we take these these open ontologies that capture this shared meaning and allow us to test our hypothesis by pivoting through the graph? Well, we need to establish standards communities to be able to support adopters. So if you've ever heard of the Linux Foundation, the Linux Foundation is the governing organization of CASE UCO. And it's governed within a project at the Linux Foundation called the Cyber Domain Ontology Project. I'm actually also the chair of that project this year. And then next year, we're actually going to appoint a new chair. But Project Vic has been involved in this, and there's actually been, I think, maybe about 60 different organizations that have been involved in the cyber domain ontology over about the last decade. So the CAC ontology, because it builds on top of the work that comes from the cyber domain ontology project, it's all aligned. All right, so everybody wants to see the stats. So the CAC ontology, it has over 35 different specialized modules, right? So if you want to talk about concepts for online undercover operations, targeting crimes against children offenders, or you want to talk about internet crimes against children task force operations, or you want to talk about CSAM and hashes. Those are all covered in these different modules. So like common or alike concepts are all in one module. So it's really easy to navigate through all the modules to then figure out which modules might you need to use, and then you can basically transform or map your content to the concepts in those modules. And so there's again there's over 2,000 classes or like nodes from the graph, and then properties that help describe those concepts even further. And there's a bunch of examples in here. Now you can visit this at cacontology.projectvic.org to see the specialized modules if you're interested. Okay, so building this with thousands of concepts is not easy. And I want to make sure that everybody understands that we did not disclose anything that might be law enforcement sensitive in this. In fact, what we did is we gathered several thousand documents from the internet, a lot of press releases from DA's offices or from sheriffs or from reputable NGOs. And these are all documents that have been published over maybe the last 15 years. And then we distilled that into this common language, this CAC ontology. Now, I mentioned earlier that the CAC ontology is built on an upper ontology called GUFO, and I described that earlier, but you can kind of see here on the left-hand side. So these like really kind of philosophical concepts like entities and events and roles and phases. Those can be applied in kind of like any domain. But now we're basically extending those concepts into the crimes against children area of discourse, right? So in our area, we talk a lot about things like coordination, right? So like how do we coordinate law enforcement efforts across borders, to find and rescue children and get them safeguarded. There's a lot of hotlines. So there's maybe a couple hundred in-hope hotlines around the world. And so, random citizens will report to their hotlines, and the hotlines will say, okay, yeah, like that's a valid thing. Let me get a hold of a police officer that can respond to this. And so on and so forth. And then when we talk about forensics in the area of child exploitation, there's some unique concepts in there that perhaps we don't use in all other areas of forensics. So we have a CAC forensics module in the CAC ontology. All right, so like how do we take all of this and then start to put it to work, right? Because we don't want to just like think about concepts like let's do something with this. All right, so I talked about earlier, the kind of those three different areas where we might get some sort of like account information. Well, that's basically like taking a report or a data source and then extracting these things. And so I'm sure we've all done that. You take your report, you map it into a spreadsheet, and then over time, maybe you've got like hundreds of rows in your spreadsheet, and then you add new columns to it. And it gets to be difficult. And then when you leave, generally that knowledge is gone, it's lost. So like, what if we could take all of these reports and forensics extractions and I don't know, like network traffic captures, and we could very quickly map all of that concept into shared meaning using these open ontologies, that CASE, UCO, crimes against children ontology, and there's others, by the way, too. And then you could take those mappings and you could then transform the original data into a graph. So once you have the graph, now we got to think about the English teacher, right? So we want to make sure that the graph is actually conforming or following the rules of the language, because when you want to share intelligence from your graph, you want to make sure that the recipient, it might be another detective, it might be a tool that you have in your pipeline. You want to make sure that that shared meaning is conformant to the standard. And then basically once you have your graph, now you can put it into a graph database, you can query it. Okay, so let's keep pulling this string a little bit. So we talked earlier about having maybe like different data sources. Well, what if you had different cases, right? So you're a detective, or maybe you work on a team with other detectives, and and last year you worked on case A, and this year you worked on case B. Well, if you could take all of the data from those cases and you could transform it into this graph intelligence, now like you can start to very quickly identify shared infrastructure, or like in this case, a shared account, right? So in both cases, account 7 shows up, and through the graph, you basically can say, hey graph, across all of my cases in the last 2 years, show me shared accounts. And so then the graph will be able to resolve that for you. Now, if you want to be even cooler, maybe you're streaming real-time data into your graph. So perhaps this isn't like a forensics thing, but this is just a cyber intelligence sort of approach. Now you could say, show me when devices are in locations that are within 50 meters. So you're able to reason through this graph. And so basically, once you have your graph database, you can build little applications that just constantly ask the graph those questions. So like anytime that you need to know something really important, if it shows up in your data, your reasoners will be able to do that for you. Now, you don't have to be a computer scientist to do this. We all have ChatGPT now, right? So again, we've got the open foundation. We've got all the shared meaning and they're free and open source ontologies that have got good governance to them. And then the graph databases, some of them are free and open source too. All right, so thinking about more of these sorts of relational questions. I'm not going to read through all these, but you could look at them. But like as an example, which accounts are linked to the same device or person across my cases? Now, once you have your data in your graph, you can ask an AI agent that has access to that graph database these questions in natural language, and you can ask it at the level of abstraction that you understand. So if you, like me, are digging through the details every day, we're gonna ask maybe more specific questions. But say you work for a sheriff who is 60 years old, maybe he or she doesn't understand all the intricate details of digging through a file system, and so they want to be able to ask questions just at a higher level of abstraction. So the ontology is able to resolve those concepts. So like as an example, we might ask a question about an iPhone 16 Pro Max, and then the sheriff will ask a question about, hey, I just want to know like what kind of phones are most predominant in cases in the last year, because maybe they don't know what an iPhone 17 Pro Max is. So if you would like to, you can copy this ChatGPT link, and it will actually show you what a query looks like, a graph-based query. And when you look at it, you're probably going to be a little bit overwhelmed. Trust me, I am too. But because we have tools like ChatGPT, now you can take these natural language questions, and you can say, hey, AI agent, go ahead and transform this into a technical graph query for me, and then send that to the graph database, and then give me, basically give me the results back. So it's pretty cool when you see this work. All right, so I don't know if we have any developers on the line, but I'll tell you that developers historically have had a tough time with coming into this area, because there's been kind of naturally a big on-ramp phase for developers. So things like ontologies and graph databases are not generally taught in computer science programs, or if they are, it's a very little tiny bit. But now, again, in this age of intelligence, I think that we've pretty much solved all those issues, and now you can ramp up in about, I don't know, like 2 hours. So I'm just going to just talk to the developers here for just a second. All right. So essentially, the way that this works is you're going to instantiate or create a case graph, a little container, and you're going to put data into it. And that data is essentially going to be aligned with CASE and UCO and CAC ontology or GUFO. And so that's basically like all of the mappings, and then you'll be able to extend that further into another language like the CAC ontology, or maybe you have a fraud ontology. And then you're going to write that or serialize that into one or two different types, validate that using SHACL, and then be able to basically, you can just push it into the graph database. Or maybe if you're using agentic AI, the agent can do all this stuff for you. So this is just really quickly what a very, very simple case graph looks like. And again, that 10th grade English teacher, she keeps showing back up, but she's really important to this. Okay, so we got to make sure that we're always using the grammar checker just to make sure that the language that we're putting in the graph is conformant. And once you do that, it's really amazing what you can do. So just a kind of another way to look at this, because sometimes you have to see these concepts from different angles. So like the first thing is create the graph, basically like test the graph using SHACL, and in the SHACL world they're called shapes. And then basically SHACL or that English teacher will come back and say, okay, like it's conformant, or no, it's not conformant. Here's the 3 or 4 things that that are wrong. Go back and make some fixes. And then once you do that, then you can get to the point where now it's totally conformant. So that's the goal here. All right, so let's go back into crimes against children, the child safeguarding community again here. So like thinking about, how might we model complex workflows that have stages and boundaries, and there's different organizations that are involved. Data has to be handed off. This is something that happens a lot in the crimes against children community. So I mentioned earlier, that there are hundreds of hotline operators. And most of them are in the InHope network. If you've ever heard of InHope, they're also a nonprofit in Europe. And if you're looking for a great nonprofit to support, InHope is absolutely fantastic. So basically, like somebody will report to the hotline, and maybe just to kind of demystify that a little bit, if most of you are in the U.S. like I am, if we encounter CSAM somewhere, just as a private citizen, like we're not going to call some like random, other person. We're going to call the police or the sheriff's department, and they're going to come and respond to it. Well, those resources don't exist in a lot of other parts of the world where they are as numerous or accessible. So this is why InHope exists, is to make sure that there's somebody in most countries that have some responsibility to be able to receive these reports. Okay, so let's just say an InHope hotline somewhere in, I don't know, Nicaragua receives a report. Then they have maybe 2 or 3 people, and they're going to do an assessment. They will decide, okay, is this something that our colleagues in police who we've got relationships with need to do, or is there maybe something that we can do by ourselves? And so that's going to be determined all within their organization. But but a lot of times they're going to do a referral, and the referral is going to be tossed over the wall to law enforcement, and law enforcement will then basically create a crimes against children investigation, and that investigation will produce phones or hard drives or whatever, and they're going to come over to the forensic lab, or maybe there is no forensic lab, and so it's just it's a deputy somewhere whose part-time responsibility is to safeguard children, and they're going to try to figure out how to examine that data using the tools that they have. So that will produce some findings, and then those findings hopefully will lead to the safeguarding of children. So this is a real world sort of example that's complex. And now if we kind of think about this in a graph in like nodes and edges, now we have the ability to preserve meaning. So now we can start to ask those more complex relational questions to the graph. And so we can ask questions about hey, how many referrals led to safeguarding actions? You could ask about the tools that were used in the forensic examination, and like we all spend a lot of money buying capabilities for our laboratories, and so there's always somebody upstairs who's asking, well, do we need all that? Do we can you justify that? And so through graph queries you can ask these relational questions that are like, well, hey, like how many referrals came from the local hotline that then resulted in us using as part of an investigative action Celebrate UFED as an example. And so if you go back to the head shed and you say, well, sir, we only used it once, then they might say, well, do we need to spend that money? But if you can go back and say, no, we used it 500 times, then that's a real good value. So it's not always about like asking investigative sorts of questions. You can ask all kinds of questions about your data in a relational way. Okay, so I talked about earlier about solving lots of problems in this age of intelligence. So like now we all have a super intelligence essentially in our pocket, and slowly getting to our work desks as well. And we're going to keep seeing more and more and more of that. So part of the ontology effort was trying to figure out how do we help adopters be able to take all of this like shared foundation and shared meaning, and then combine that with the ability to pivot through that and test hypotheses and ask these relational questions. Well, we needed some more technology to get there, to be able to bridge the gap. So something else that I've put out, and you can see the link down there. My handle on GitHub is Volnmaster. So I've got the CASE UCO SDK that's pinned at the very top of my repository. And what this lets you do is when you clone it, you basically can install an MCP server. If you've never heard of an MCP server, it just stands for Model Context Protocol. This is like kind of the de facto standard that AI agents want to communicate through. So you can install the SDK's MCP server. You can power it with with a model that you are allowed to show your data to. So maybe if you just want to do like testing, power it with OpenAI models or Anthropic models or Grok or something like that. And if you want to show it law enforcement data, well, you're going to have to probably use a different model. Maybe your agency has a language model service, or you can run a local model as well. So anyhow, now you have this MCP server that's powered by a language model. Together, that's an AI agent, right? So agents are all about a language model that's given tools, and then given rules to govern how it's supposed to operate. So if you ever heard of like an AI agent, that's what that actually means. So now you can give the agent your data and your intent, right? So you'll say, hey, I've got 57 reports from cases last year that I worked on, and I need you, agent, to analyze this and convert it all into knowledge graphs. And I want you to use, in this case, CASE UCO. And if you need CAC ontology, then you can use that too. And then what happens under the hood is this SDK agent is able to do all the mapping for you. It does all the modeling. It hires the English teacher, does all the validation. And then from there, you can tell your agent, hey, like go and put this into, as an example, like an Apache Genofuseki graph database. That's open source through the Apache Foundation. And very quickly, you could just tell your agent, like, go download, Apache Genofuseki and install it for me, and then put my data into it, and then help me understand, like, how to test hypothesis. And now your agent can do it, but your agent is now grounded in these open ontologies, right? So it's really grounding all of its queries, and so you're going to see like very, very little content that's made up because it's grounded in this shared meaning. So if you want to, you can download this. If you're a developer, you probably start to understand how this could be really, really helpful. So you can automate this, and actually there are people that I work with who are heavily automating this at this point. So there are, for the developers in the crowd, there are bindings in the SDK. So if you want to write your automation in Python, C#, Java, or Rust, the SDK supports that. The bindings are in the SDK, and hopefully in the next couple of months, we're going to actually publish them into the various language distros. Okay, so we talked about the SDK being able to solve lots of problems for adopters and make this really simple. So like if you called me up and spent, say, 15 minutes, like literally, I could show I could show your mom essentially how to do this. So like it is really that simple. So going back to the cyber domain investigator, now, like, you've got all this investigation data, you give it to your AI agent that's powering the CASE UCO SDK. Under the hood, the SDK is starting to understand or the agent's starting to understand really quickly what kind of content you just gave it. Like, is this legal process data? Is it mobile forensics? Is it, crimes against children evidence? Is it like court filings or like identities or log data or whatever? And then it basically then routes it through, there's about 84 different recipes for modeling all kinds of different things. Think about like, various iOS log formats, or just Linux operating system logs, or call data. So we can model all of those things. And actually the SDK does the modeling for you. And now the SDK gives you the knowledge graph. And so you can use the SDK to insert the knowledge graphs that are produced into your graph database. And now maybe you've got, like a current investigation, you got a prior case, and you want to find like, different things that correlate across those cases. You can do that now very, very easily. Okay, so I didn't just make this and put it out there. So like I really wanted people to be able to use this. So I want to highlight actually a really young colleague of mine named Renal Ramachandran is his name, and he's a graduate student at UMass in Massachusetts. And he's a computer scientist, but he's also really interested in criminology. And so I seen him posting on LinkedIn about some things that he was looking at. I was like, oh, that's really interesting. But it became apparent to me pretty quickly that he wasn't using any sort of like, like open foundation and shared meaning. So I talked to him about these ontologies. I gave him the SDK, and very quickly, I don't know, like within a day or so. He came back and he goes, "Oh my gosh, like I've got a graph database that is now modeling 7,400 different crimes against children cases." And those cases came from 56 different sources. It includes references to over 30 different tech platforms. These are reports that have come from every single ICAC task force, and so he's been able to do this and able to do that mapping and modeling and English teacher SHACL validation, and then produce 7,400 knowledge graphs. And actually, it's probably more than that. Actually, it's 7,400 cases, and so now he's able to ask questions to this data. So what he's really looking at is trying to find recurring patterns to basically kind of test his theories of intervention, which is really neat. But then he's not just looking at the child exploitation problem, but he's looking broadly across all kinds of different types of criminal investigation. So he's like, is there kind of a common pattern to all of it? And if so, is it something that's so fundamental that we could employ as technologists to then intervene or perhaps defeat these things? So if you're interested in learning more about his work, he's also starting to volunteer with us here, but you can see the links to his work down below. So if you're really interested in just kind of like the science of criminology, this is really neat stuff. Okay, so at Project Vic, we are a nonprofit charity, but we're a tech company. And so we've been working on building technologies for a long time that we provide to crimes against children investigators all over the world. And now that we have this ontological foundation, we're eating our own dog food, right? So all of our capabilities in our ecosystem are all built on this semantic foundation. So if we're doing forensics, we can export, everything that's been done and identified by our forensics capability into these CASE, UCO, CAC ontology knowledge graphs. If we're helping with a child abduction case, same thing. If we're doing warrant return analysis, same thing. If we're doing some some more kind of technical, interesting things like media authentication. So I try to determine, is an image or a video original, edited, or AI generated. There's a lot of analytic capabilities behind the scenes, and every one of those capabilities has components in code. They all serialize or create knowledge graphs, and then that all streams to a common graph database in our ecosystem. So we're doing this. And you can do it too. It's really a great time to jump in with AI and do development, because the things that you thought I could never make that, or we could never afford to make that, I'm telling you now, you probably can, especially if it's kind of on the simple end. If you're interested in learning more about how to do this agentic AI development, Project Vic actually has a free course on this. If you go to projectvic.org/training and you scroll down a little bit, you're going to start to see that there's two GitHub repositories. One of them is a presentation, and then the other one is a sort of a guided repository for your agent and you to follow. And all you have to do is just start to communicate your ideas. But it's not vibe coding. It's actually what we call spec-based engineering. And so if you want to make something for your law enforcement environment, well, you might only be focused on the one thing that you care about, but at the end of the day, it might be impossible to actually get that on your accredited law enforcement network, because maybe you don't know anything about CJIS cybersecurity controls. Well, that guided repo will actually help do that for you. If you're interested in more, you can always reach out to me. Down there in the bottom right hand, you can see use the help. So at projectvic.org, there's a help button on the bottom right of every single page. And basically me and my team, we're on the other side of that. So if there's anything that you want to talk further about, that's the best way to get a hold of me. All right, so just as a recap, a shared language makes connections usable and the data interoperable. And so you benefit greatly by having these open foundations, this shared meeting, the ability to pivot, ask questions, hypothesize, and then also be able to engage in these open communities should you be interested. One thing that I failed to mention, which I think is important, is sometimes you might give this SDK data that it's never seen before, or like types of data it's never seen before. Well, the agent will actually update recipes that exist and even write new recipes. If there's no coverage in the ontology for your concept, which happens sometimes, the SDK has the ability to research and write a change proposal that can then go right back to UCO or right to the CASE ontology or to the CAC ontology GitHub. And then humans can like get working and make sure that the coverage gaps are filled. And lastly, we are a nonprofit charity here in the United States. And so we are basically driven by financial sponsors. A lot of our sponsors are like, $5 and $10 a month sponsors. So if you're interested, visit projectvic.org. We use a site called givelively.org. And so you can, if you want, if you're interested in sponsoring this kind of work, you can make a donation there and then receive a tax receipt in return. So all of these open things that we're doing, like CAC ontology, we spent thousands of dollars being able to assemble this. The SDK is probably many thousands of dollars to build that. And so we made it free and open. And so you guys can run with it, but we definitely need some support. And then there's a lot of things going on behind the scenes that are a bit more law enforcement sensitive. And so if you're interested in us being able to further help the thousands and thousands of crimes against children investigators, we really could use your help. So thank you so much for the time, and I will take any questions that you have.
Okay, great. Thanks, Cory. That was an excellent presentation. I know we do have some questions in the chat, but I'll ask one or two myself. I get the feeling from the ontology discussion. I know with AI, like lots of non-traditional programmers can build around systems like this, but I would imagine for most folks in the sort of ICAC community, this ontology would largely be opaque to them, like sitting behind some kind of application interface, right? So they wouldn't necessarily be interacting with it directly, but they would be benefiting from its implementation, right? So like they'd have some kind of interface where they can then run searches or look for links and connections, and the ontology is what's empowering that ability, right? That's kind of like the sort of broad view of this, right? Is that we're developing a system that allows these connections so that investigators can use them instead of having like all these disparate, unsynchronized data sources all over the place.
Yeah, absolutely. I mean, there's lots of levels that you can engage with this technology at, right? So you can use the SDK and build your own data transformation pipeline and put it in a graph database. Again, like all of that is completely free and open source, and you can do it really rapidly. But then you say, well, maybe, I don't know, maybe that's a little too technical for me, and I just want to like be able to ask these questions. Well, you maybe one of your colleagues stands up this graph database in your department or your company, and now you can use ChatGPT and you can build little, like web apps that then access that graph database behind the scenes, right. Or maybe you're using an agent, like Claude Code or Hermes. If you never used the Hermes agent, it's very cool, free and open source as well. And so the agents can do this. You can build web apps. You can build these little inference engines to reason, right? So if you're like, I need to know if my data ever shows, this sort of thing, or like these three or four things. So like, I don't know, maybe you're in the military service, and your commander has got like, intelligence priorities. Well, you can take those intelligence priorities, you can create these graph database queries, and then you can basically build like a web app that has I don't know, a stoplight chart or something for the commander, and basically the whole web app's job is just to like, hey, every 5 minutes, query the graph database and see if it actually returns back anything, and if so, like, make the stoplight chart red, so
Yeah.
so the commander can see it on the on the dashboard or whatever. Yeah. So you can do all kinds of things like that. You don't have to be super technical, and really AI is here to help you. It's getting better and better every day.
Right, Megan, do you want to run through some of the questions that we've got?
Yeah. So we did have a couple of questions come in the chat here. The first one's from Dean, and I can partially answer this. He was wondering if the slides would be provided. We are going to provide the recording. Corey, if you're comfortable sharing the
Sure.
slides
Mhm.
with attendees as well, we're happy to send those out for you. So we'll take care of it
Absolutely.
offline.
Mhm.
Fantastic. Thank you. Next, we've got a question from Lori. This, I believe, came in on the slide where you were just talking about the like different levels of the ontologies with like the upper, middle, and lower. The question is, why is legal process before exploitation patterns? Lori, correct me if I had that background wrong.
And Cory, you can probably see these questions in the chat yourself so that
Mhm.
you can
Yep.
follow along. Yeah.
I can. Lori, thank you for the question. I'm trying to think back. Okay, so when we think about legal process, legal process is like an area that maybe we would cover in the case investigation ontology. And then exploitation patterns are something that we're going to cover in the other application ontology, which in our case is the crimes against children ontology. So there's not like a reason why legal process might be mentioned in the slide before exploitation patterns. They are different conceptual areas at the end of the day, and I think that's what I was really trying to illustrate there. Is that each of those topical areas, fit within like different modules in these ontologies.
All right, awesome.
Okay, and then she also asked a question about how often are drones being utilized by offenders. That's interesting. From what I'm seeing, not a lot. Most of the exploitation that's happening right now is kind of like one of three things. Number one, is it's familial, right? So it's just trust-based relationships that adults, want to take advantage and prey on children, and they do that through, oftentimes familial relationships. Um, Number two is online, and this is really bad, and is like, it's a million times worse than it was like maybe 10 years ago. And so we're seeing a tremendous amount of different types of elicitation and grooming and sextortion that's happening through the internet. It's reaching our children right on their smartphones, right in the apps that they use. And you know what? If you're in school, you better be on Snapchat or you're going to be made fun of, right? And so guess where the offenders like to go? Right into the apps that our children are using. And then thirdly is through trafficking. And so trafficking is a bit different because fundamentally it's a money making enterprise that's behind the scenes. So like, certainly trafficking can lead to hands-on exploitation. But drones, not saying that yet. Although I do have a really cool idea. If anybody here is into like drone engineering, I'm really interested in exploring an idea of being able to replicate the kinds of abilities that our electronic sniffing canines have, and be able to so there are some sensors out there for for kind of like being able to replicate that. And I'm really interested in, like, can we put that on a low cost drone, and then let that low cost drone, do that kind of job? Because I know we all love our dogs. I have two of them. And I know that every department out there would love to have, a series of canines, but they're very expensive. There are some amazing nonprofits out there, that also are looking for donations and support, that raise these canines, that train them, that get them into police departments. But then they're only able to serve, for a handful of years. And I know that the departments that have them, they love them. So, but we're never going to be able to train enough of those canines for this service. So if we can use drones, to fill the gap, if you're interested, I'd love to talk to you about it.
All right, we also have a hand raised from Lori. So Lori, if you have a question you wanted to ask live, let me give you controls to talk over
Okay.
microphone. Lori, you'll probably have to unmute to ask your question.
How's that?
We
Hi,
can hear you.
Lori.
Hi, I asked a question about the drone specifically. My background was in campus law enforcement at a college campus. And I had an incident that occurred approximately 5 years ago that really kind of made me take a couple steps back. A man approached me in my squad and said that his drone had crashed on campus. And I said, well, let me go and see if our grounds people picked it up. So one of the grounds employees, a student employee actually, did pick it up. And he said that it was still running. I didn't really know much about drones at that time. And he said, but I need to let you know there's something wrong with this. And I'm like, what do you mean? He said that drone was flying over the childcare playground when it crashed. And lo and behold, because I don't believe in coincidences, when I went back with the drone to this guy who was supposedly going to wait for me to return it to him, he was gone and never came back for that drone.
Mm-hmm. Yeah, yeah. I mean, I'm not surprised by that. We definitely see lots of, lots of pedophiles essentially that, will go to beaches and take pictures of children, or sit outside the local elementary school and take pictures of the kids on the playground. So using a drone for that sort of thing, if that's what was going on, it's not surprising, but it's not something that I'm hearing a lot about. It doesn't mean that it doesn't happen, but it's not something that's generally on my radar right now.
And then the one thing I will finish with is my grandson, well, I just dated myself, recently told me that he suspected he's seen a lot more chats in the kids' VR headsets that they're using. So I didn't know if you were aware of that or not.
Oh yeah, yeah, yeah. So it's really a matter of where our kids are in cyberspace. That's where offenders are too. And we have a problem in this area where there's a never-ending supply of people that want to take, adults generally, that want to take advantage of children. So we have to be very vigilant about what our kids are using.
What?
And then making sure that, if you are part of an organization that is developing these applications, that you're designing them in such a way, to be able to prevent this stuff.
Which pickles?
Causes.
I
Okay.
temporarily muted Lori because I think
Yeah. It sounds like somebody walked up to her.
Yeah.
So I see another great question from Dean. He asked about any way I can help. I have a degree in computer science, administration of criminal justice, retired detective, done some programming. Can't provide money. That's perfectly fine. And he did these child exploitation cases. So Dean, look. Absolutely. We have about 30 volunteers today that serve on our board or our steering committee, or they're technical volunteers. And so we're always welcoming more people, who maybe are not in law enforcement exactly, but they have capabilities and desire to be able to help. So Project Vic is certainly a nonprofit and a platform where people can do that. So if you have that background, I'd love to talk to you. Just drop me a note via the help button at projectvic.org, and I'd love to catch up.
I'm going to paste Project Vic's website in the chat and we'll send it out in the email with the recording as well, so you guys have access to that. We're about at time here, so I think we'll call it for questions. Thank you so much, Cory, for doing this presentation today. It's really, really insightful. Just the work that Project Vic does is just so important. Like, really, we appreciate your time.
Yeah, this is great,
Absolutely.
Cory. Yeah, thank you for doing this. And this is going to be a great video to watch a few times over because it's such deep technical content here. So I'm glad to, it'll be nice to have this recording and throw it on the channel so that people can watch it over and over again and really let some of these concepts sink in. So,
Yeah,
but
and
thank you for your time.
I would just invite anybody who, who wants to like have a walkthrough of the SDK and kind of see how it works, and maybe do a little side by side, even if it's virtual. Happy to help you with that. But I'm telling you, like within a couple of minutes, when you see what it can do and that you can do it too, it's really a game changer.
Cool.
Fantastic. Well, thank you everybody for attending today. We really appreciate you taking some time to sit in on this webinar with us, and hope you guys have a great rest of your couple of weeks until we do another workshop Wednesday. And thanks again, Cory, for taking your time to present today. We really appreciate it.
Okay. Yeah, and Desiree just dropped me a note at the help via the help button at projectvic.org, and I'd be happy to find some time.
All right, great. Thanks, everybody. Have a great day.
All
Thank
right,
you.
thanks.
Bye.